Hello, my name is Toqeer Mahmood. I am working as assistant professor in the Department of Computer Science, National Textile University, Faisalabad, Pakistan. I have published many scientific papers in conferences and journals of international repute. I am also serving as academic editor of mathematical problems in engineering. I have also supervised many students at undergraduate, graduate, and postgraduate levels. Currently, I am supervising 3 groups at undergraduate level, 10 students at graduate level, and 2 students at postgraduate level. The students in my research group are mainly working in image processing, machine learning, and multimedia forensics. Before presenting a research paper titled Automated Accessibility Evaluation of Mobile Applications in Initial Stages of Design and Development, I would like to thank the Committee of International Conference on Software Engineering and Machine Learning for inviting me as a keynote speaker. Here are the presentation outline of the topic to present, like introduction, research aim, gap of the gap of the research, uh, objectives of the research, the proposed methodology of the proposed method, results, and finally we shall conclude the study. The growth of users' reliance on smartphones increases as new features and functions are continuously added to these technologies. Accessibility is an essential characteristic of information architecture and interface design. There is a need to focus on accessibility to minimize the efforts, cost, and time during mobile application design and development. Most of the applications available on the App or Play Stores lack the accessibility guidelines during development because implementing these aspects requires sufficient time and resources. Here, the accessibility means to make a system usable by maximum people. The concept of accessibility is derived from software equality. Accessibility ensures equal, easy access to information and provides standard guidelines to improve the quality of interaction. Accessibility evaluation means evaluating a system according to accessibility standards, and these standards are defined by WCAG guidelines under W3C organization. The underlying research intends to develop an automated accessibility analysis and design evaluation tool for mobile applications. This will focus to find out how web content accessibility guidelines can be applied on design phase of mobile applications. Accordingly, we have developed a solution as a plugin for Figma. After research and analysis, we found that there exist some tools for evaluation of mobile applications accessibility, but they mostly evaluate source code of that application, which means that after the system is developed and resources are allocated, they perform accessibility evaluation, and if severe issues are identified, it may affect the development life cycle, deadlines, or overall budget of the system. Moreover, the existing evaluation tools are required to install and set up for IDE, which returns test cases or do code analysis and show errors to the user. The objectives of the research were to perform system analysis and design, analyze WCAG 2.1 techniques that can be automated, study Figma API to identify which techniques could be automated, keeping in mind the limitation of the API, report generation, and implementation of the plugin. Before we jump into the methodology, I would like to briefly describe the layers of guidelines that WCAG provides. There are four principles in WCAG that includes perceivable, operable, understandable, and robust, which are further segregated into assessment matrix for communication technologies. Let's see this from an example from WCAG website on the next slides. So here first we can see principle is perceivable. Then it has many guidelines, and every guideline has many success criterion, and each success criteria has many techniques. We have chosen a few techniques from WCAG 2.1 to develop this plugin. Out of all the techniques, we selected these techniques to carry out our research. Here the success criteria and the associated techniques by which these success criteria can be evaluated are mentioned. The developed plugin uses this methodology to evaluate the design in Figma. User opens figma.com. Open one of the design. If he does not have a design, he should first create something to run the plugin. Select a frame and select the plugin. If the plugin is not found, user must install it first in the Figma. When user runs the plugin on the selected frame, the plugin evaluates the screen according to selected techniques that are automated in this research. If all criterion are satisfied, plugin shows success results. Otherwise, it will show failures and suggest corrections. Let us discuss the results that we have achieved in this research. On this page, the plugin throws error for violation of technique C36, which we can easily see in the before image and after image. The C36 technique defines that the text spacing override without loss of content or functionality, such as line height spacing, letter spacing, or word spacing. So this is the first screen which is showing the properly. However, when our technique is applied to the text override or overlapping, which shows it is not fulfilling the rules of C36 technique. So in this situation, our tool indicates that on home screen of this application, in some particular frame, COVID-19, that is a text overlapping problem, and indicates to allow adjusting the text properties to avoid such situation according to the technique C36. The technique G179 explains the content or functionality should not lost while increasing the text size to 200%. However, we can see here the screen after increasing the text size is showing issues like the text is lost, the text is overlapping, and the size of the text container is increased. Thus, the report is showing all of the errors found in the design screen. G183 techniques says that links should be differentiated from the regular text so that users know if it is a link or not. Link mean to say a web link. So here we can see that the web link clearly visible, however for some people it may not be visible. Therefore it does not satisfy the accessibility check here. So that the plugin uh, shows the same problem as discussed in the previous slide, indicating the contrast ratio. Furthermore, if the web link is underlined to differentiate the web link from the regular text as shown here, then our plugin will show that the criterion is satisfied, which can be seen in this report generated by the plugin. So coming to the conclusion and future work of this plugin, we observe that the plugin works well when the direct parent of node is a frame. The frame exists in the Figma tool because we get more control using frame in Figma API. Moreover, proper meaning of nodes or design elements is important to plugin work effectively. To do this, UI kit makers can play an important part to design components in a standard way using standard naming conventions so that the plugin can work completely in an automated way. It will help the plugins to work dynamically with reduced human efforts to evaluate the accessibility of design. So it's all about our research. Thank you.